Okay, so today we just looked at really we didn't actually, the title says multiply, but we didn't do any multiplication of complex numbers. What we did was we looked at exercise 8.3 on 223, and we looked at question 9, in particular plotting points. It was just more of what we did yesterday, but just a small little bit extra. So we put up an Argand diagram, which you can see here on screen. So we took the Argand diagram here, and we took question number 9, we plotted the points, 2 plus 3i, and minus 2 plus 5i. Well, let's just take minus 2 plus 5i, and we just look exactly what we did here, just so we're clear in it. So this is minus 2 plus 5i here, minus 2 on the real, 5i on the imaginary, and we just plot it up there. It's very like plotting xy on the xy axis. There's nothing different on that. Then we plotted, this is 2 plus 3i, this is minus 1 plus 4i, minus 1 in the real, 4i in the y. Just a reminder, if you're wondering which is real, which is imaginary, this is the real axis, this is the imaginary axis, and your easy way to remember it is the I is already formed by the axis, and you just put the dot on top of it. Part 2 of that question, you were asked to evaluate the following. So we were given evaluate z1 plus a W-type sign is from the Greek alphabet, it's the letter omega. So that's what this looks like here. So Z1 plus W. So, excuse the handwriting. So Z1 was 2 plus 3i plus 1 plus I. We literally take the real bits on this side. So that was 2 plus 1. Take the imaginary bits over on this side. That's 3i plus I. We add them together, we get 3 plus 4i. And then we have to plot that up in the Argand diagram, which we did here. And there you can see it over here. We plotted 3 plus 4i over in the Argand diagram over here. Then we had Z3 plus omega. Watch the minus, so we brought the minus over here, minus 1 plus 1, which is, this is the real bits, and then the imaginary bits. We add up again, we got 0 plus 5i, we have to put that up in the Argand diagram. This is 0 plus 5i up here. And that's what we did. Just one final question, describe the transformation. When we are adding in complex numbers, what does it do to the point? It literally moves it. It doesn't move it across an axis. It doesn't move it through a point on the far side, and it doesn't rotate it, okay? A rotation, and we just listed the different types of transformations that you can have. That was from your junior cert. There was translations, axial symmetry, central symmetry, and rotations. In complex numbers, you can have translations, and really you can have rotations as well. You can also have what are called dilations, slightly different. But you don't have to worry about this morning. I just want you to know that when you're doing adding in complex numbers, you're simply moving a point from one position to another, and that's also called a translation, which is what this was. So adding in complex numbers, this can come up as a question, but I've yet to see it come up, okay? So the homework I've given tonight is question 10, which is almost the exact same as question 9. If you can do that for me, then on Monday we'll move on with multiplication of complex numbers. Tuesday we'll move on with a little bit more around finding the complex conjugate. On Monday we're going to do not rotation or multiplication, we will do the modulus, I think, on Monday. Yeah, the modulus on Monday, which is pretty straightforward. Multiplying more on Tuesday, and Wednesday we'll be doing dividing, which is very much like multiplying, and then Thursday, Friday we'll try and hit the exam questions. Alright, that will do for today. I'll talk to you on Monday.